Today we're going to take a look at a topic that is not involved with your project, but it is something that you will get quizzed on next week, and that is on standard deviation and measures of spread. So starting off there, standard deviation, what that is it's a description of the spread of the data from the mean, how far we have a variance or a deviation. Measures of spread is going to be that idea of the range with the standard deviation and to describe how varied or different the data set is. And a great example of talking about measure of spread is our bell curve. As you can see here, a bell curve is this normal distribution of data. If you take a look at this picture here, you will see that we have this line right here. This line right here represents our mean. And when we take a look, you see that we have these two 34.1%. At this point here and this point here, this is what we call one standard deviation away from the mean. And this is where 68.2% of our population of whatever it is we're serving, if it falls in a normal distribution, it will fall within here. And then as you can see, we've got another set of lines that's right here, and we've got these 13.6%. And if you take that 27.2% and add it to our 68.2, this says that 95.4% fall within two standard deviations of the norm or of the average or the mean, because that is where the majority of our population, for instance, in IQ, you will have a few people that will fall in here and a few people that will fall in here. And those are going to be what you would consider your outliers. So today we're going to use that knowledge to be able to identify if we have any outliers in a data set. So let's start off first by reviewing the idea of range. We have our phone bill here for January through June with the following prices, and we want to calculate the range and talk about what it says about the data. So that first thing we'll do is calculate that range, which, if you recall, is your highest value minus your lowest value. So if I go ahead and do that, as you can see, this is an example we've done before. So we're going to take our 48 minus our 29, and when you subtract that, you get 19. So then we want to ask ourselves, does this seem reasonable for our data set? And when we talk about reasonableness, we really want to focus on the specific content. So if I look at this, and I'm talking about a phone bill, we expect phone bills from month to month to be pretty much on the same range. And so $19 is a pretty big spread. So we're going to say no, because phone bills should be similar. And this is, now if this had been a range of 19 and you were talking about ages of people in school, that's not a very big deviation, because that's what you would expect to see, a wide range of people in school. Alright, so now that we've had a chance to review range, let's start talking about this whole concept of standard deviation. So we've got this first example here. We have the 10 most home runs by a batter, or by batters, in the 2013 season. We have them listed here. We have a standard deviation of 4 and a mean of 44. And we want to interpret this. Now, first I'm going to talk about this mean of 4 here. What that means is that each deviation will be 4 home runs. And so the first thing we really want to do is to ask ourselves, is it a large deviation or a small deviation? If it's large, it means there's a varied set of data. If it's small, it means a similar set of data. Now, when I think about baseball, I don't consider 4 home runs to be tremendously huge. So I'm going to go ahead and say that this is a small deviation. Go ahead and get a pen, I apologize. I'm going to say a small deviation and similar data. And so now that we've had a chance to do that, the next part we're going to talk about is this whole idea of outliers. So we're going to talk about how we can get this, but if you think about it, if you think about this bell curve, we're saying that right here is our 44, which is our mean. And our standard deviation is 4. So that means that one standard deviation up, we would add 4 to that mean to say 48, and we would subtract 4 to get 40. And then if we want to look at 2 standard deviations to get that idea of outliers, I would see 52 and 36. Now the easier way to do it, so you don't have to draw the bell curve each time, would be to, like it says in step 2, to multiply that deviation by 2 and then add or subtract it with the mean to get these values. So as you can see, 4 times 2 is 8, and if I add 8 to 44, I get 52. If I subtract it, I get 36. If there are values that fall above or below those high and low values, then you have outliers. As I look here, my highest value is 51, my lowest value is 39, neither of which fall in there, so I'm going to go ahead and say no outliers. So now let's go ahead and take a look at the next example. The wait time at the DMV are these following numbers. We have a standard deviation of 3.5 and a mean of 7.2. So we want to interpret this. So when I look at that standard deviation of 3.5, personally, I've been to the DMV. I don't consider that to be a long wait because 3.5 minutes is pretty darn quick. So I'm going to say that that is a small deviation or small variation. Make that V better. So then that would be that, as you can remember from our information up here, it is a similar set of data. And you can see that by looking at the numbers. Because as you can see here, we have everything from 2 minutes to 14 minutes. Not a huge variation. So now when we talk about this outlier idea, we're going to take our standard deviation of 3.5 and we're going to multiply that by 2. And when I do that, I get 7. So now I'm going to take my mean of 7.2 and I'm going to add 7 to it, which will go 2 standard deviations up, and that gives me 14.2. But I see that my highest value here is 14, which is below the 14.2, so I don't have a high outlier. Then if I look and go the other way, 2 standard deviations down, I will take 7.2 minus the 7, and that gives me 0.2. And when I look at my list, the smallest value I have is 2, which is quite a bit higher than the 0.2. So I can safely say that there are no outliers. Looking at my final example, we got a price of cell phones here as follows. The standard deviation is $72 with a mean of $139.50. When I take a look at this, $72 is pretty significant, especially seeing as how we've got phones ranging in price from $35 to $300. So I would have to say here that this is a large variation, and that means we have varied data. And so then when I take a look at this, I have my $72, and I'm going to double that to get my 2 standard deviations up, so I get $144. When I take the mean of $139.50 and I add to it $144, I get a value of $283.50. And so when I look here, I do have a $300 phone. So I do have an outlier of $300 on the high end. Now when I look on the low end and take $139.50 and I take it minus $144, I don't even need to finish this because I'm going to get a negative value, and there were no phones, unfortunately, that they were going to pay you to take off their hands. So you wouldn't have it on that end. But I can safely go ahead and say that $300 is an outlier. So what I need you to go ahead and do now is to go ahead and try the You Try problem. Bring your questions with you to class tomorrow.